Hello Math Magicians, here we are. It's Notes Lesson 10.4. We're going to use the Pythagorean Theorem to come up with a new formula. It's called the distance formula. But before we begin, you need to get this drawing on your paper. So you might want to pause the video right now to get this drawn, to get this sketched onto your paper. Okay, so pause the video, get this sketched, and then start it back up. Okay, welcome back. Here we go. Let's say we're trying to find this distance right here. So we'll call it C. And it's running diagonally, so it's hard to actually tell how far that is. So what you would do is you'd use the Pythagorean theorem. You'd build a right triangle, and then you'd measure this distance. Now it's a horizontal distance, so it's easy to tell how far that is. You went from 2 to 7, so that's 5. And then this distance, and it's a vertical distance, so it's easy to tell how far that is. You went from 9 to 15, which is 6. And then to find the distance you really want, you're going to go leg squared plus leg squared equals hypotenuse squared. 5 squared plus 6 squared equals C squared. Now, we don't want C squared, really. We want just regular C. So then you'd end up, eventually, taking the square root of both sides. Okay, now, we're going to do the same kind of problem, but with algebra. All right, so let's say we want to find how long this is. And let's call that D. Okay, we need the points. We need the endpoints. So I'm going to call this the first point. So I'm going to label it x1, y1. And this is the second point. So I'm going to call it x2, y2. Now let's build a right triangle, just like I did before. We'll build a right triangle. And I'll need this point right here. Well, to get to that point, to get to this point, I went over x1 up y1. To get to this point, I went over x2 up y2. So to get to this one, I'm going to go over not x1, but all the way over x2, but only up as far as this. I'm going over x2, but only up this far. So that point's going to be x2, y1. Okay, here we go. We can find this distance right here. So how did I find this one? Well, I went from 2 to 7. Can't you just figure that out by going 7 minus 2? What's 7 minus 2? 5. So I took the x numbers, the x coordinates, and subtracted them. So I'm going to take the x's and subtract them. So it's going to be x2 minus x1. Now to find this distance, I just went 15 minus 9, right, to get 6. From 15 to 9, you subtract, which are the y coordinates, the y values. So the y values are y sub 2 minus y sub 1. And now I use the Pythagorean theorem. Leg squared, x sub 2 minus x sub 1 squared, plus the other leg squared, y sub 2 minus y sub 1 quantity squared is going to equal d squared. But again, I don't want d squared, I want regular d, so I'll take the square root of both sides. And you will get the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared equals d. And that is what's known as the distance formula. And it comes directly out of the Pythagorean theorem. All right, let's use it. Now what I did here is I explained where the formula came from, but really and truly, all you need to know is, it helps to kind of understand where it came from, but you just need to have this memorized, basically. All right, let's try a couple examples. Example number 1. Let's say you want to know how far it is from negative 2, 1 to 2, 5. And you don't want to graph it, and you don't want to get a ruler out to measure it. You use the distance formula. So the distance formula is the square root of x2 minus x1 quantity squared plus y sub 2 minus y sub 1 quantity squared equals d. All right, you might want to label your points x1, y1. Those are both first, and these are second. Second x, second y. And then you just plug them in. Square root of x2 minus x1, so 2 minus negative 2, quantity squared, plus second y minus first y, 5 minus 1, quantity squared, and that's going to equal d. Now just follow your order of operations. A double negative makes positive, so 2 take away a negative 2, that's really 2 plus 2, that's 4. 4 squared is 16. And then 5 minus 1 is 4. 4 squared is 16. And you cannot split up this radical because of the plus. You can't split it up. So 16 plus 16 is 32, so the square root of 32 equals d. 16 has a perfect square in it. I'm sorry, 32 has a perfect square in it. So 32 is 16 times 2, right? And because that is multiplied, you can split this apart. Square root of 16 times the square root of 2. And you would get 4 square root of 2 is your distance. And you need to know what you're measuring it in. If you don't know, you just write units. It could be miles or feet or inches. So you want to know how far it is from one point to the next? Just use this handy-dandy distance formula. All right, let's try one more. So this is example number 2. Let's say you're trying to find the distance from negative 10 to, from negative 10, negative 6 to 6, 2. You might want to label this x and y number 1, and this is x and y number 2. I think it helps to write the distance formula. Second x minus first x, quantity squared. Second y minus first y, quantity squared. And then let's take the square root of all that is d. All right, here we go. Square root of second x minus first x. 6, take away negative 10. Quantity squared. Plus second y minus first y. Second y minus first y. 2, take away negative 6. Quantity squared. And you take the square root of all that equals d. 6 take away negative, that's plus. That's 16 squared. Two take away negative 6, that's actually plus, that would be 8, and then squared. You cannot split this radical apart because of addition, so keep going. 16 squared. 16 times 16 is 256. 8 times 8, 64. Do not split this apart. You cannot split it apart because of the addition. 256 plus 64 is 320. But 320 has a perfect square of 64. It has a perfect square factor. So 64 times 5, actually. Now you can split it apart because you have a product, you have multiplication. And you would get 8 square root of 5. And again, we'll say it's units. It could be miles, feet, inches. We don't know really because this isn't a story problem. All right, I hope this is helpful. Good luck.